CleoCATra, my calico cat from Egypt, absolutely loves fetching little rubber balls launched with my mini trebuchet and bringing them back. A cat that actually does something useful. That's a rare thing indeed. In fact, you can see her in the background there because she's hoping that I'm going to use it. I'm David, and I enjoy putting together STEM projects. For those of you unfamiliar with the term, that's science, technology, engineering, and maths. And the idea for the medieval counterweight trebuchet came to me when I was teaching secondary school history, and I developed it into a project that involved physics and a scientific method as well as maths. And in this video, I explain step by step how to build my mini trebuchet. I've deliberately designed it to be constructed with only a few basic tools so that it's accessible to more people. And that's why in this build, I use only basic equipment. My trebuchet is not intended to be an exact replica, but a working model that uses the same scientific and engineering concepts as the originals. With the right weight, it'll hurl a small object up to 15 meters, which is pretty impressive when you think that the throwing arm is only 300 millimeters long from there to there. Okay, on with the construction. And just to say here that you may see some branded products in this video, but I'm not paid to advertise anything. To keep it simple, for the most part, you only need to saw, cut, and glue. I have even designed the pivot points so that no holes need to be drilled. You can see them here and here. Let's begin by looking at the equipment you need. First, a junior hacksaw, which can be bought cheaply online if you're in the UK. A craft knife, scissors, a pencil, ruler, and set square, and a small amount of sandpaper. It's useful to be able to clamp while you're gluing. If you don't have small clamps, I've just used cheap plastic ones. You can make do with good clothes pegs or binder clips. And I also use masking tape and little cable ties to hold pieces in place while they're gluing. If you're not using one of my supplied kits, you'll need a pair of long nose pliers as well as pliers that can cut 2mm thickness wire. And then you need glue. Either white wood glue or epoxy will work. The advantage to epoxy is that it cures quickly. Also, wood glue isn't the best for gluing the pin at the end of the throwing arm. Here. I actually use both wood glue for most of the build and epoxy where appropriate, and you'll see as I go along. Whatever glue you use though, do buy good quality. Having a small bench hook to hold the wood while you're sawing is a good idea, and you can make one from scrap. I've deliberately used materials that are inexpensive and easy to source. I'm in the UK and have bought everything online. Also, the materials I've chosen are easy to work with, so that you can build your trebuchet at home or in a classroom. You can also buy the trebuchet kit containing all the materials from me. You can see details about that in the description. Anyway, whether you source your own materials or get my kit, you can build a trebuchet using the instructions in this video. Let's look at the materials that you're going to need. First of all, 6 pieces of 300mm long 12 by 12 wood, then 14 pieces of 6mm by 6mm strip wood, 1 300mm length of dowel, 6mm in diameter, a piece of leatherette, very thin leatherette. You want it to be 115mm long by 38mm wide, about 1.5 meters of cord. This is about 1.5mm in diameter. A very small screw eye, 4 6mm washers, a approximately 150mm length of 2mm diameter wire, and an A4 sheet of 3mm thick plywood. For simplicity, the instructions in this video are sequenced in 3 sections: the base, the throwing arm, and the counterweight chest. As you build, it's quicker to move backwards and forwards among the 3 as you wait for the glue to dry or cure on the various parts. We're going to start by making the base. To begin with, on a piece of scrap card, draw a rectangle 300mm by 145mm. You don't have to do this, but it makes putting together the base easier. And we're going to be making the base out of 4 pieces of 12mm square strip wood. It'll look like this, roughly. There are the 2 long sections of the base, and then
This over here, another one, will be the center cross piece, and the fourth piece is going to be cut into two pieces of 145 millimeters long each, and they will go on the ends.
Now for each of the two side pieces, measure and mark 180 millimeters from one end. Then measure and mark up the center piece so that the same amount protrudes on either side of the frame. This is what the cross piece looks like in position. Glue on the end pieces and cross piece and fix them down with masking tape while the glue dries. Put some books on top to add pressure, but do be careful as you do so that the pieces don't move. Let's look at the uprights, which are also 12 millimeter square pieces. Cut these 275 millimeters long and keep the offcuts. Cut out a 6.5 by 12 millimeter piece from the end of each one. The two pieces should be identical. Hold each short piece and long piece together like this and check that a 6 millimeter dowel will turn freely. Use sandpaper glued to a thin stick such as an ice cream stick to make adjustments if necessary, and then glue and clamp the pieces. Set the uprights in place using clamps and a set square to make sure that they are perfectly perpendicular. Triangulation makes frames strong. Begin with the rear struts as you can see in the video. Measure the angle at the base of the strut and then cut it. Glue the top of the strut against the side of the upright. It's easier to use a clamp at the top and a piece of masking tape at the bottom. The front struts are done in the same way. You can see here why cross struts are also needed. Hold the pieces against the frame while you mark them up for cutting. After the pieces have been cut to the right length and the correct angles, then glue and clamp. To complete the frame, glue in the launching chute, which in the kit is a pre-cut piece of 3 millimeter plywood, 300 millimeters long by 48 millimeters wide, and the two side rails are 6 millimeter square pieces. Right, that's the frame finished. Now let's build the throwing arm. For this we will use 3 pieces of 6 millimeter square rod. The first piece is full length, 300 millimeters. Then from one of the other pieces cut at 195 millimeter length, a 70 millimeter length, and another length of 15 millimeters. From the third length, cut a piece 145 millimeters long, another of 83 millimeters, and a third of 45 millimeters. Next, cut 2 pieces of 6 millimeter dowel rod, one of them 130 millimeters in length and the other 80 millimeters. That's all the pieces for the throwing arm. Let's glue it up. First, the throwing arm pivot. Glue the longer of the 2 dowel rods to the 83 millimeter wood strip as you see on the screen. Use cable ties to hold the pieces together while the glue sets. And do the same for the counterweight pivot using the smaller piece of dowel and the 45 millimeter piece of strip wood. I'm pointing at the 300 millimeter square rod. It needs to be glued to the 195 millimeter one with an overlap of 85 millimeters. Then glue the 145 millimeter long piece on the other side so that it's the same length as the 195 millimeter rod. And this is where cable ties are very useful. Now mark the center of the larger pivot axle. Glue the surfaces and insert it. Make sure you put it the right way around. I don't know how much of a difference it makes, but I've deliberately done it this way because I believe it's stronger given the forces involved. Make sure that it's in the center and at an angle of 90 degrees to the arm. Glue in the 70 millimeter piece, making sure that there's glue on all the surfaces that come into contact with each other. And then glue in the counterweight pivot axle. Check your measurements at every stage. When I was building this one, the counterweight pivot axle set skew because it shifted after gluing, and I had to break it and reset it. Lastly, glue in the 15 millimeter length at the counterweight end. Now we're going to add the launching pin and make the sling. My release pin is made of 2mm diameter wire. It protrudes 10mm past the end of the throwing arm, and there's a loop 10mm inboard. The one in my kit is pre-bent into shape. If you want to make your own, you'll need pliers. Glue the pin in with a generous amount of epoxy and hold it in place with cable ties. When the glue has properly set, angle the release pin upwards slightly, about 25 degrees to begin with. The angle of the pin is very important because for maximum distance, you want the projectile to launch at an angle of 45 degrees. And if the pin is set at too shallow an angle, the sling will release too early and the projectile might go straight up or even backwards. If the pin's angle is too great, the sling will release too late and might just throw the projectile into the ground in front of the trebuchet. If you don't have a pair of pliers, adjust the pin by holding the throwing arm and pressing down on the pin on a hard surface. This was a throwing arm test that I did on my prototype trebuchet. You can see that the projectile launched at an angle of about 30 degrees. That's not optimal and indicated that the throwing arm pin should be set a little shallower. Something else, you can see here that the projectile seemed to dip very slightly just before it left the pouch. I think that's because I used a washer to connect the sling to the release pin, and that dragging its weight caused the pouch not to open as efficiently as it could have. So now I've replaced the washer with a tiny cable tie. Now to make the pouch for the sling, I've used leatherette, 38mm wide by 100mm long. It's very thin, which is what you want, nice and flexible. I've also made two little patches. They're about 15mm by 15mm, and they're going to be for strengthening where we tie the lines. As I said at the beginning, you can use epoxy, but because I have fabric glue, I'm going to try that out as a bit of an experiment. Let's streamline it a bit by cutting the corners off. The sling needs to be the same length as the distance from the pivot to the release pin or finger, and I think we've got that. And I've put a little bit of glue on all of the knots to stop them unraveling. This is the pouch for one of my prototypes. As you can see, I punched holes and made little knots in the corners. The idea of that was to stop the projectile falling out the side, but in my most recent ones I found that it hasn't really been necessary. Maybe if you use a marble it might come out the side. I don't know. You'll have to experiment. These are the pieces for the counterweight chest. There are 5 of them. This is the base. It's 71 by 90mm. Then there are 2 sides of 70 by 90 and a back and front of 70 and 65 each. Let's have a look at how those go together. Now we're going to glue up the counterweight chest, and the easiest way to do that is to use masking tape and to tape up the 4 sides. Now to do the hangers, we're using 3 lengths of 6mm square wood, and we cut those into 4 lengths of 150mm each, 2 of 80 and 2 of 15. There they are glued up. To adjust the slit so that the dowel rod will fit easily into it, get a thin piece of stick and glue some sandpaper onto it, rather like a little file. These have got to go in here. So you have to measure there and there.
As with the other aspects of the build, lining everything up is really important.
Now to test that the hangers fit, they can be quite tight on the slits, but must be loose at the top where they actually make contact with the dowel.
Now we're going to make a release hook. If you're using my kit, there's already one made up. I've got a piece of 2mm thick wire. It's about 110mm long. That's not crucial because we're going to cut a bit off. We're going to start by making this bit over here that fits over the screw eye. This part here in this prototype is only 15mm long. I'm going to make it 20. I'll use a Sharpie to mark it. And this is obviously much longer than it needs to be. You're going to want to cut it about there, so about 20mm. And there it is. Fit that on there. And close it off. You can see that there are two holes here. This one was for a different release mechanism. But just to show you where it goes, very slightly to the left of the throwing off. Having made a little indentation in there, I'm now going to screw this in. Can even use this as kind of a spanner. And if I didn't have such close inspection, it would be easier. I guess you're just making sure that I get it completely right, you know. Is that okay, Cleo? It is right, I promise you. You'll see in a minute, watch. And I pull it, and it releases.
Now to the final assembly. This is where we use the washers.
When you're launching projectiles, attach a pull cord here.
I hope you found that useful. If you made the trebuchet, please let me know how you got on and whether you made any modifications. I'd be interested to hear. So from me and my helper, whose assistance resulted in me having to remake various sections of this video, best wishes and happy launching.